Okay guys, in previous videos I showed you how to do parts A, B, C for the normal distribution for this problem. Now I'm going to show you how to do part D. And part D is slightly different because in this case it says how big does the return have to be in the top 10%. So we're kind of looking in reverse here. We're going to want to find the X this time, not the probability. We have the probability, which is the same thing as the area under the curve, the 10%. So let's see how we approach this. All right, in this case, we are going to start with the probability statement. So what's the probability that X is bigger than X1 is equal to 10%. How do we know to put bigger than? Let's look at the sketch. When you see the sketch, it says here the top 10%. So you have to have it has to be greater than, because it says the top 10%. If the question said the bottom 10%, then this would have to be a less than sign right here. Okay, so that's how we know to put a greater than in this case. Our next step is to just go ahead and rewrite X in terms of Z. So where we see the X, put a Z, and then this is the same 10%. So just repeat that. Then this is greater than, so it's not in cumulative form just yet. Cumulative has to be less than, not greater than. And so to do that, we're going to subtract from 1. 1 minus this left hand side gives us less than. 1 minus this right hand side gives us 0.9. So remember, in algebra, whatever you do to the left hand side, you have to do to the right hand side. So that's what's going on. So we got that done. Our next step, now this is in cumulative form, so we're ready to go to the normal table. And let's go ahead and go over there. Let me erase this right here. All right, so let's go ahead and look in the normal tables. And we're going to look for 0.09 in the body of the table. So we're looking in reverse, remember. In this case, we have the probability, and we're trying to find the Z value. And so that's what we're doing. So the 0.9 might not be there precisely, but we can go between the two closest values to 0.9. So let me show you what the actual normal tables look like from what we used earlier. So this is what we have, okay? So again, I'm looking for 0.9 in the body of the table. So I'm going to go all the way until I see 0.9. If I don't see it, I'm going to go between the two closest values, which in this case would be 0.8997, this value right here, and 0.9015. So I'm going to go across to the row, and I'm going to get 1.2. I'm not done yet. I'm going to go to the column to get the third digit, which is 0.08. Technically speaking, we could add another digit to that, so 1.28, maybe 2, or 1.281, because of how the numbers, because the 0.9 is closer to this number than this number, right? But for right now, just go ahead and use 1.28, right? So again, you get the first two digits here on the row, and you get that third digit over on the column, the 8. And so what we have is Z1 is 1.28. We're not done yet, because remember, we want the return. Right now, what we have is the Z value corresponding to that X. So we have to convert the Z back to X. And so we use the same Z-score formula that we had before. And all we're going to do now is use some algebra to make X the subject of the equation. And so we do that. We multiply by sigma to get it times Z. And then we add mu to both sides to get it here. So X is equal to mu plus sigma times Z. We have all these values from before. So it's 14.4 plus 4.4 times 1.28. Put that in your calculator, you get a value of 20.03 for your X value, or the return that cuts off the top 10% of returns.